Assalamualaikum and good day everyone. Today our group will present our project title Analysis of COVID-19 Death using application of least square method and best fit quadratic curve. This project focuses on analyzing COVID-19 death trends in Malaysia using the least square method. We use mathematical modeling to determine the best fit quadratic curve and evaluate how accurate the model is in representing real world data. Before we begin, let me introduce our team members, which consists of four people: me, Ameh, Alia, Alisa, and also Hazira. Throughout this project, our responsibilities included determining the best fit quadratic curve, performing calculation using least square method, and also evaluating the accuracy of the mathematical model. COVID-19 has significantly affected the whole world, including Malaysia. During the pandemic, a large number of death cases were reported over time. Because of this, analyzing the trend of death cases is important to understand how the situation developed throughout the pandemic. In this project, we analyzed COVID-19 death data from April 2021 until January 2022. The data was obtained from the Malaysia Ministry of Health COVID-19 dashboard. We used the least square method to determine the best fit quadratic curve and also evaluate the model's accuracy. A total of 10 data points were used, where variable x represents the month index and variable y represents the number of recorded death cases. Our project consists of three main objectives. The first objective is to analyze the trend of COVID-19 death cases in Malaysia from April 2021 until January 2022. The second objective is to determine the best fit quadratic equation using the least square method. Lastly, we aim to evaluate the accuracy of the model by calculating the error vector and the magnitude of error. These objectives help us understand how mathematical models can be applied to real-world data.
So next, I will be presenting our data collection and analysis regarding COVID-19 mortality trends in Malaysia. To conduct this study, we gather monthly COVID-19 death cases directly from the Malaysia Ministry of Health COVID-19 dashboard. We selected a total of 10 specific data points spanning from April 2021 to January 2022. To analyze this mathematically, we set two variables where X represents the month index from April 2021 to January 2022, while Y represents the corresponding number of COVID-19 death cases recorded for each month. If we look closely at the table, we can see a very distinct pattern. We start at month 1 with 258 deaths. Then the number climbs rapidly, spiking heavily in month 4 with over 6,600 deaths and reaching a stark peak in month 5 with 8,872 deaths. After this peak, the number began a steady continuous decline, dropping back down to 435 cases by month 10. This brings us to an important question. Why are we using a quadratic model to represent this data instead of a simpler linear model? There are four primary reasons for this choice. First, the data shows a clear curve trend. As I just mentioned, the COVID-19 death data doesn't just go straight up or straight down. It rises to a sharp peak and then decreases, naturally forming an upside down U or curve pattern. Second, a quadratic model allows us to represent turning points. Linear equations go on forever in one direction, but a quadratic model can mathematically capture a maximum or minimum point. In our specific data set, it allows us to perfectly capture the moment death cases peak before they began to decrease. Third, it provides a much better fit compared to a linear model. If we try to force a straight linear line through this data, it would completely miss the reality of the situation and fail to represent the heavy fluctuations in the COVID-19 death trend. Finally, this data is highly suitable for least squares approximation because the data naturally follows a curved path. Applying a quadratic model through the least squares method minimizes the overall error between our observed real-world data and our predicted mathematical values. This ultimately gives a much more accurate and reliable model for our study. Assalamualaikum. My name is Nur Alicia binti Azli, and I will be presenting the calculation part of our project, which focus on the least squares method and quadratic regression analysis. In this part, we apply the least square method using a quadratic model, which is y equals to a plus bx plus cx squared. We choose a quadratic model because the data trend is not linear. Since the data increases and decreases in a curve pattern, so a quadratic equation is more suitable to represent the trend, and we arrange the data into matrix form using the values of 1, x, and x squared. After forming the matrix, we calculate the two important matrices, which are A transpose A and A transpose B, because this calculation helps to simplify the system and allow us to solve the unknown coefficient, which are A, B, and C. Since we have more data points than unknown variables, we cannot solve the system directly. Therefore, the least squares method is used to find the best fit curve that minimizes the total error between the actual data and the predicted values. Next, we check whether the system has a unique solution by calculating the determinant of A transpose A. Since the determinant value obtained is 435600 and it's not equal to 0, it means the matrix is invertible and the system has a unique solution. After that, we use row reduction or elementary row operation to solve the augmented matrix and find the values of the coefficient A, B, and C. From the calculation, we obtain the final quadratic equation is y equals to negative 32719 over 12 plus 1389479 over 440x minus 79379 over 264x squared. So this equation represents the best fit quadratic curve for the pandemic trend data. Although the curve may not pass through every data point exactly, it gives the closest overall approximation to the actual data. Next, we're going to obtain the quadratic equation by calculating the error vector using E equals to B minus AX. In this formula, B represents the actual observed data, while AX represents the predicted values from the model. So the error vector shows the difference between the actual values and the predicted values for each data points. Next, we calculate the magnitude of the error vector, and the result is 5311.927, which represents the overall error of the model. Since the error is not zero, it is still acceptable because real pandemic data is affected by many external factors such as reporting delays, movement restriction, and changes in public behavior. Therefore, the quadratic model may not predict every value perfectly, but it still provides a good mathematical representation of the overall trend.
As you can see from the graph, the best fit curve is obtained. The graph illustrates quadratic regression curve that models the relationship between the month index X and the monthly number of COVID-19 deaths Y. The curve shows a nonlinear trend where the number of deaths changes direction over the 10-month period. The data is moderately scattered around the curve, meaning the quadratic model captures the general trend but has some deviations, particularly around the peak months. And the line of the best fit curve indicates a nonlinear relationship, showing an initial increase in death followed by a steady decrease. Next, I'm going to present the analysis of the graph. The type of best fit curve is quadratic and the error magnitude is 5311.927. As the month index increases from month 1 to month 5, the number of deaths rises sharply, peaking at month 5. From month 5 onward to month 10, the trend reverses, showing a steady decrease in death as the month progresses. The actual data points are moderately scattered around the line of best fit, with the model underestimating the true peak at month 4 and 5.
In conclusion, the COVID-19 death data in Malaysia from April 2021 until January 2022 was successfully analyzed using the least square method. The best fit quadratic curve was obtained using the 10 selected data points. Since the data showed a nonlinear trend, with an increase followed by a decrease, the quadratic model was chosen as the most suitable model. The results show that the quadratic curve predicts the actual data quite accurately. Therefore, this project demonstrates that mathematical modeling and least square approximation are effective tools for representing and analyzing real-world data trends. Thank you for listening.